So first of all, what is a magnet? Now, a magnet is something which can attract, and the magnet has two poles, north and the south poles. And magnets are classified into two categories: permanent magnets that do not lose their magnetism, example bar magnets. Temporary magnets can be magnetized and demagnetized, example iron and steel. Now, around a magnet, there is a specific area where we can feel the magnetic force, and that area is the magnetic field. Now, across the bar magnets, you should be able to draw a magnetic field across a solenoid and across a current carrying conductor. Now, if there's a bar magnet, it has two poles, north to south, and field line starts from the north and go towards south. So you'll be drawing the circles and making the arrows from north to south. For a current carrying conductor, you'll be applying the Fleming's right-hand thumb rule. Now, the thumb, if they point in the direction of the current, then the fingers will give you the direction of the magnetic field. So if the current is going upwards, see your fingers' directions of the right hand. It is going in an anti-clockwise. On the other hand, if the current is down, magnetic fields of line will be going clockwise. So field lines are according to the right-hand thumb rule. Thumb points in the direction of the current and the finger gives the magnetic fields of line. If the current is upwards, the magnetic field is anti-clockwise. If the current is downwards, the magnetic field line is clockwise. Now, for a solenoid, what is a solenoid? It's a coil of wire. Now, inside the solenoid, the field lines are straight and then it forms a loop outside. The solenoid also has a north pole and a south pole. The north pole is where the current is anti-clockwise and south pole is where current is clockwise. Now, you should be able to draw these magnetic fields of line in the exams. Now, next is what is an electromagnet. Now, electromagnet is something like this. It is a solenoid, that is a coil of wire, which is wound around an iron core. Now, when you pass a current through the solenoid, then the iron core becomes magnetized. And you can use this magnetism of the inside core in the scrapyard crane, in the circuit breakers, in the electric bell, and in the relays. Now let's see that how this works. In an electric bell, you can see that there is a solenoid which is wrapped around an iron core. Okay, and then there's an ammeter. Now, when we pass the current, this solenoid, the iron core becomes magnetized and it attracts the ammeter towards itself. As the ammeter is attracted, it rings the bell. So when the switch is closed, the current flows through the electromagnet. The iron core will become magnetized and will attract the ammeter, which will ring the bell. The same thing works in the scrapyard crane. It has an electromagnet which is magnetized and then it attracts the scrap. And when it is demagnetized, it leaves the scrap. In the circuit breakers, it is an electromagnet which is magnetized with a large flow of current and it attracts the switch towards itself, turning off the current. Now let's see how a relay works. A relay is a device where a small amount of current will move the current in the electromagnet and it will make this core magnetized. As the core will get magnetized, the iron ammeter will be attracted towards this electromagnet and the switch gap will be closed. As the switch gap will be closed, the current will flow through the motor. So a small amount of current in the device will give a greater current. So again, the electromagnet attracts the ammeter. Ammeter closes the switch gap so that the current flows and it switches on the motor. Okay, so you should be able to define the electromagnet for the exam and the various applications of the electromagnet. Now let's see a very important concept. What is motor effect? Now, motor effect says that when you place a current carrying wire in a magnetic field, it experiences a force. The force can be increased by increasing the current, taking a stronger magnet, and placing the coil perpendicular to the magnetic field. Now let's see how we find out how much will be the force and what will be the direction of the force. Now, for the direction of the force, we'll be using the Fleming's left-hand rule, where first finger will point in the direction of magnetic field, the center finger will give the direction of the current, and then the thumb will give the direction of the force. And the value of the force can be calculated numerically by using the formula BIL, where F is the force on the conductor, which is given in newtons, B is the magnetic flux density, which is given in Tesla, I is the current flowing through the conductor, and L is the length of the conductor. Now let's see how the setup of the motor works. Now look in this figure. We have a tube magnet north and the south, and you know that the magnetic field is from north to south. Now, since the magnetic field is north to south, then the field lines will be this way. Now you have placed a coil here, and the coil is connected to the split ring commutators, which have the metal or the graphite brushes, and the current passes through it. And the current is flowing upwards in this part of the coil and downwards in this part of the coil. Now let us see the Fleming's left-hand rule, and let us concentrate on this part. If you see this part, my magnetic field of line is left to right. The current is moving upwards. So my center finger will go upwards. What I will see that the current is going downwards, that this force is going downwards. As the force is going downwards, this part of the coil will move down. Let's see the Fleming's left-hand rule on the other part of the coil. On this part, my current, that is the center finger, is downwards. The magnetic field is left to right. So my thumb is pointing upwards. So this part is going upwards. As a result, my motor, the coil will flip from here to here and here to here. Now, as the coil flips, after the half a turn, the split ring commutator will reverse the current. So the part of the coil which is moving downwards now move upwards, and the one which is moving downwards now move upwards. And then this cycle repeats and the coil keeps on rotating. And this is what is a principle of an electric motor. So see Fleming left-hand rule. Use this first finger, center finger, and the thumb, and find the direction of the force. The other side will be on the opposite side. So there's a flipping. After half a turn, again to and fro, and the cycle continues. So what's the function of the split ring commutator? To reverse the current after each off cycle. Okay, so this is the principle of the motor effect. Make sure you are able to draw this, explain where the motor and the coil will rotate using the Fleming's left-hand rule. Now let us see what is a generator effect. Up till now we have seen if you have a current, you can generate a magnetic field. If you have the magnetic field and the current, you can take the force. Now what we will be doing, we will be using the magnet and producing the current. This is the generator effect. Generator effect says that when a magnet is moved inside and outside of the wire, it produces a current in the wire due to the electromagnetic induction. And how we can see that? We can take a coil of the magnet, a coil of wire, and move the magnet in and out. As the magnet will move in and out, it will cut the magnetic fields of line, and as it cuts the magnetic fields of line, we will see the deflection in the galvanometer. And if we reverse the direction of the magnet moving in and out, the deflection will be in the opposite one. So if the magnet is moved in the opposite direction, the deflection is in the opposite direction. Moving the wire or moving the coil has the same effect, as both cuts the magnetic field of line, and when the wire is connected to a bulb, the bulb will light up. And this is what is generator effect. So generator effect is generating electricity using magnetism by cutting the magnetic fields of line and doing electromagnetic induction. Now let's see how we use that in an alternating current generator. So in an alternating current generator, we have a magnetic field. We place a coil inside the magnetic field and we connect it to the slip rings. Now you can see that for the top slip ring, one end of the coil is connected, and to the bottom, the other coil is connected. Now, what will happen when this coil rotates, and the split ring will be rotating it? When this coil is rotating, it will cut the magnetic fields of line and it will be generating an alternating current. So we will see a graph like this. We will see a high voltage, then voltage coming to zero, then a high voltage in the opposite direction, and the voltage coming to zero. The voltage will be zero when the coil is perpendicular to the magnetic field. Okay, and when the coil is parallel to the magnetic field, we see the maximum voltage. So when the coil is parallel in the magnetic field, we see the maximum voltage, and when the coil is in the opposite direction but still parallel, we will see the maximum voltage in the reverse direction. So you should be able to draw this setup, know the function of each of the component, and should be able to explain this graph, why we are getting the peak and why we are getting a zero voltage. So in an alternating current generator, a coil is rotated in a magnetic field. The rotating coil cuts the magnetic fields of line and produces an electric current through electromagnetic induction. You have the slip rings that allow the coil to swing easily, and you have the brushes which allow current to flow from the split rings. And the voltage is zero as the coil is perpendicular to the direction of magnetic field, and the voltage is maximum as the coil is parallel to the direction of the magnetic field. Now let's see a dynamo. A dynamo is a direct current generator where you have the north and the south pole and the coil which is connected just to the split ring commutator, and you have a voltmeter. So a motor has a slip ring commutator instead of slip ring. So due to this commutator, the current is not reversed. So it gives a DC current just in one direction, and that's what is a dynamo. Now you can use this electromagnetic induction in the microphones and the loudspeakers. So you can see this setup of a loudspeaker. There's a permanent magnet and there's a paper cone which is a coil of wire which is like an electromagnet, and an alternating current passed through it. So current is switched on and it generates a magnetic field which interacts with the permanent magnetic field and produces a force, and when the current reverses the direction of the force also reverses, so that can generate the sound waves. Okay, so now the last thing we need to do is what is a transformers. Now, transformers is a device which is used to increase or decrease the voltage of the potential difference. To increase the voltage, we have the step-up transformer, and to decrease the voltage, we have the step-down transformer. Now, what we have in a transformer, we have an iron core, and on this iron core, the coil is wound, and we have a primary coil and the secondary coil. The primary coil is connected to an alternating current. Remember, transformers works in the alternating current because the varying current will produce a different magnetic field. Now, understand the principle. This is very important. The primary coil is connected to an alternating current supply, which is an input voltage. Changing the electric current in the primary coil creates a magnetic field, and the changing magnetic field, when it cuts the secondary coil, it produces a voltage. And that's what our principle is, that we give an input voltage and we get the output voltage. We need more output voltage, that is the step-up transformer, we increase the coils of the secondary. If we need less, that means we need to do a step-down transformer, we will decrease the coils of the secondary. So you need to do the transformer calculation. Voltage in primary over voltage in secondary is equal to the number of turns of primary over number of turns of secondary. The power across primary is calculated by voltage across primary times current across primary, and power across secondary is calculated as voltage across secondary times current across secondary. And as per transformer efficiency, if it's 100% efficient, then the power in primary and secondary is same. So we equate the two. Now let's see what kind of a maths question can come according to using this formula. So if the number of turns in primary is 20, that is NP is 20, and input voltage is 230, that is VP is 230, what are the numbers of turns in secondary, that is NS, you need to calculate when the voltage in secondary is 460 volts. So we'll write this like this and use this expression. VP over VS is NP over NS. So NS would be NP times Vs over Vp. So that is 20 times 460 divided by 230. It means there are 40 turns in the secondary coil. Now, next question is, a transformer's input voltage is 230 volts and the current is 20 amps. What is the output voltage if the output current is 10 amps? So we'll use the transformer efficiency expression. Vp is 230, Ip is 20, Vs we have to find, Is is 10 amps. So we'll do Vp times Ip is Vs times Is. So we'll rearrange this equation. Vp times Ip is 230 times 20 divided by Is, which is 10, gives 460 volt as the output voltage. Okay, so there could be different questions asked that can ask you to find the voltage across primary, secondary, or the number of turns, or the power. So make sure you remember these expressions and how to use them. Okay, so now what's a national grid? So in a national grid, we have a power station. Power station is connected to a step-up transformer. Now you need to remember why we use a step-up transformer for transmission, because increasing the voltage for transmission increases the voltage and decreases the current. Now current causes heating effect and it can cause loss of energy. So high current causes heating and result in loss of energy. So by increasing the voltage and lowering the current, you can prevent the energy loss. So the transmission is efficient. And before the energy reaches the house, we use a step-down transformer to bring it down to 230 volts so that it is safe to use in the homes. So for transmission, we take a high voltage and a low current, but inside the home supply, we need the low voltage and the high current. So therefore, we have two types of transformers, and now we're doing the difference between them. Make sure you remember them. Step-up transformers is used to increase the voltage. Step-down transformers is used to decrease the voltage. Step-up transformer has more turns in secondary than primary. Step-down has more turns in primary than secondary. Now, in the step-up transformer, voltage in secondary is greater, so Is times Ns is greater. And in the step-down, voltage in secondary is lower, so Is times Ns is lower than the primary. The step-up transformers is connected next to the power station to transmit high voltage to reduce the heating effects of current during transmission, and step-down transformer is connected to the lower power supply before it reaches home to reduce the voltage to 230 volts. Okay, so I hope this concept is clear to you. Now you should be able to define these terms: magnet, magnetic fields of lines, induced magnetism, north pole, south pole, solenoids, electromagnets, relays, circuit breakers, electric bell, motor effect, Fleming's left-hand rule, magnetic flux densities, flickering commutator, electromagnetic induction, generator effect, alternator, dynamo, transformers, step-up transformer, transformer efficiency, and national grid. Have a pause of this video, try these questions. If you still have any problem, do watch the video again. So now, as always, our next step, check the specification, make sure everything which is there in the specification is crystal clear to you. Do exam questions on this topic can be found on my website. The link is shared in the description box below. If you like this video, then do subscribe to the channel and do click the bell icon next to it so that you're notified as soon as I put a new video. And if there's any specific topic you want me to put a video on, leave a comment below and I'll make sure I'll have that up and running before your next exam. Okay, so I'll see you next in the next video. Till then, happy revising.